Alright, so this is my lesson for Circumcenter and Incenter. I'm currently in the back room with Mr. Brown in a Zoom meeting. You've already seen Incenter on Thursday. Let me just review Incenter since it is going to be on our homework tonight. So I'm trying out a new tool here, seeing if our electronic compass will work here. So Incenter, there's a few things that I want to have for the notes. First of all, Incenter is asking, is an answer to the question. The question is, what is the largest, can't type here, largest circle that can fit inside of a triangle? And the answer is, if you do angle bisectors for each of the interior angles of a triangle, you should find the incenter. So let's go ahead and try this out. Let's grab our compass. Again, if you remember how to do an angle bisector, I want the metal needle over here. Drag this to some random length, and this is going to be in the way. Let's move you over here. And then I just moved to a random length here. Yeah, just go ahead and make a tick mark here. And I guess I can move it all the way up here as well. It doesn't really matter. Move your metal needle to one of those intersections, and then you know that it's going to be somewhere out here. Again, it doesn't matter if your compass changes lengths. This is always going to be in the way, isn't it? Maybe I can move this down here for now. And there should be a tick mark out here. Move this metal needle to the other intersection, and we should be able to have this intersection right here. All right, cool. So there is our first angle bisector. If I go ahead and grab a line tool here, I'm getting a ton of lag using this program. I might have to switch to a different program. I'm just going to draw it really, really long. There's your first angle bisector, and then you just do it again. So come back here, grab our compass, and you can keep the same length. It's fine. Let's have it come over here and shrink. Going to go ahead and make those two tick marks. Grab your compass, metal needle goes to one of those intersections, and we should have some form of intersection out here somewhere. So I'm just going to make, and then this is totally unrelated to this first line. The fact that this intersects this line right here does not matter. And go ahead and grab the metal needle, move it to our next intersection. Oh wow, it's really, really close to actually being on the line though, isn't it? And there's our next intersection. We're done with the compass. We can move that away and grab our second line here, if my computer would be my friend and not lag. And again, I'll kind of extend that beyond where it needs to. And we see that the incenter is right here, so we can come back here and we can make this a new point. Maybe I can make it blue. This point right here, let's label that incenter. Incenter. Wow, I don't know if you guys are seeing the lag that's on my end, but there it is. And you don't have to construct the circle because we don't actually know how to do it yet. But if that was the center of the circle and the maximum distance from the center of the circle to something that's actually, you do know how to construct it, because if you, as long as you make a perpendicular line through this line that goes through this point, then you should have a circle, because the circle will intersect wherever that perpendicular area is. Is it perpendicular there, there, right? You'll construct that wherever it's perpendicular through that line, and that will be the point. Let's say it was there, and then that would be a point on the circle. You could go ahead and come back to your compass. You could measure the distance between this point and the point that's perpendicular through that point, through this line, and that circle would perfectly fit in there. I thought that we didn't know how to do it, but we do. Cool, so I'll leave that there. And the next thing, the new thing for today, is the circumcenter. And this is asking another question, or this is an answer to another question, and that question is, what is the smallest circle that you can draw around the triangle? And the answer here, instead of angle bisection, it is just a perpendicular, I can't spell, perpendicular bisectors. So bisector meaning we need to bisect the line in half, and perpendicular bisectors is one of those easier ones, right? So I have a feeling that the text is going to be in the way. I'm going to preemptively move it down here. It seemed like it was a good place last time. Let's grab our compass tool again. And it randomly changed to blue, I think, probably because I changed the pen tool to blue. I want to change it back to black. So the way that perpendicular bisection works is you want the metal needle at one of the vertices, and you need this to have a length that is at least half, and I hope that's at least half. It looks like it is. And then you're going to make, I don't know exactly where it's going to be. I'm going to do a giant sweeping arc up here, and then a giant arc down here. And we're going to move our metal needle to our next vertice, and we can see that it intersects right there. Just need to make a tiny tick mark, and somewhere down here, right there. Cool. And then our compass is done for now. We grab our line tool, and we have a line, please, if it works. I'm probably going to have to move it in a sec, but it should go through at least one of those intersections. And oh yeah, actually it looks like I got it through that one as well. I didn't know if I would have to move it. I can tweak it just a little bit here and here. Come on now. That looks good. Yeah, so that definitely looks like it's 90 degrees to our line that we were constructing around. And then you do another one. You do a second one. And I didn't say it before on this slide, but you only need 2 of these angle bisections. If you do a third, it will also intersect through this incenter. That third can verify that you did it correctly, but 2 is enough. 2 is sufficient because the intersection of 2 lines is a point. And same thing with this one. We've constructed 1 line for a circumcenter. We just need 1 more perpendicular bisector, and we are done. That third one you can use to just verify, I guess, if you want. I realized that I should use maybe a smaller line segment, so I'm going to choose this smaller one over here. Okay, don't need it to be as long because, again, I'm just measuring the distance, at least half the distance between here and here. So let me go ahead. I think that's a good length, and I have a tick mark out there. Go ahead and rotate this. I have a feeling that I might have to do weird things. Oops. Uh-oh. That's not what I meant to do. I wanted to just be able to draw this without this. If this green dot goes off the screen, then I can't get it back again. So let's bring all the way back. There we go. Move the metal needle to the next intersection mark. And then I want to use this tool. Where is our intersection? It looks like it's going to be right there. And, oh man, I have to move it back to move the green circle back. And over here, I didn't draw it long enough. Darn it. Okay, well, it happens sometimes, right? That means I have to move the metal needle back to our first vertice. And if I do that, this green dot is going to be off the screen. So let me rotate it first. And continue this line going down. Does it match up? It was pretty darn close without me moving that right. I don't want to move the length here. So it just means that my vertex wasn't exactly correct. And it's probably because my line is a little bit too thick here. But it's pretty darn close. So let's go ahead and make our perpendicular bisector. And notice that for this circumcenter, the circumcenter is going to be outside of the circle. So looks like we have it. Go ahead and change our color to blue again. So there is our circumcenter. We can label that. That is our Circumcenter. And yeah, we have done it by construction. So we're all done. The one question that I have for you guys, just right now, without you playing with this on Desmos, because eventually you will be doing that on Desmos, is what type of triangle will have a circumcenter inside the triangle, and what type of triangle will have a circumcenter outside? So inside and outside, I think those are the two. And then the third type is, when will the circumcenter be on one of the line segments of the triangle? Because I could have had the circumcenter like right there. What type of triangle will generate that? So my homework for you guys, or my classwork rather for you guys, is to make at least one more incenter, draw another random triangle, make an incenter, draw another triangle, and do another circumcenter. So you should have 2 of these, 2 of each, one with me, one by yourself. And then I want you to try doing both an incenter and a circumcenter just randomly with GeoGebra. And then with GeoGebra, you should be able to drag around these points for the circumcenter to figure out exactly what type of triangle generates a circumcenter that's inside, outside, or on the line segment of the triangle. And then after you do the paper, after you do the GeoGebra, then you can do the homework, which again is going to be on GeoGebra. All right, that concludes our lesson for today. I will see you guys in person tomorrow.